Hi, everyone. Thank you so much for joining us. Our webinar will start in 1 minute. We'll give everyone just a second to join us, and we'll start at 1 minute exactly. Thank you. So hi, everyone, and thanks for joining our webinar, Improve Performance at Less Cost with AWS Graviton and Continuous Optimization. A brief overview of what we'll be going over today, an overview of AWS Graviton and Amazon EC2, including benefits and ecosystem. We'll be going over SundaySky's performance optimization journey from AWS Graviton migration and internal methods. We'll introduce Granulate's continuous workload optimization solution and move forward to benchmarking AWS Graviton. We'll then go over real-life results, how SundaySky unlocked more performance and further reduced costs. We'll then progress to the Q&A session and finish with resources and next steps. I'd like to introduce the people that will be joining us today. So Yuval Kenigsbuch from SundaySky, Senior Backend Engineer, Michael Lanthier from AWS, Partner Solution Architect, and Bar Yochai Shaya from Granulate, Global Director of Solution Engineering. I'll now like to present Yuval. Thank you for joining us, and the stage is yours.
Hi everyone, my name is Yuval. I'm working with SundaySky for more than 12 years, which is forever. And at SundaySky, we have a platform to generate videos, personalized videos for various use cases. And one of them is our ads solution, which I'll present in a minute. Okay, so at SundaySky, we have a real-time bidding system. Our platform allows our customers to create videos and to present personalized ads, video ads to the users. As a real-time bidding system, it handles 35 billion requests per day, more or less. We give between 5 and 20 million bids per day. So as you can probably understand, it's a system that has a lot of heavy lifting. It all runs on AWS. And one of the things in our system is that for every request that we get, we need to respond within 50 milliseconds. So this is like a general diagram of our architecture. Like I said, everything runs on AWS. We have our load balancer, and behind it we have our EC2 instances. It all runs behind auto-scaling groups, and we use Redshift, we use DynamoDB, and a lot of services from AWS to run the whole system. Okay. So, like I said, we need to respond within 50 milliseconds to each request, which means that every change we make to our system and every system decision have a lot of impact. So we measure our performance all the time. We use several systems for that. One of them is CloudWatch, AWS CloudWatch, in which, as you can see, we monitor the number of instances we run, the CPU utilization on each instance, the number of requests, and what is very important for us is the bid time, which is the actual response time to each request. So in order to measure our performance, we actually use we split our traffic between two auto-scaling groups. We use the AWS application load balancer, which splits the traffic evenly between the two auto-scaling groups. And so in this way, every time we make some changes to our system, every deployment first goes to one of the groups, and then we can see if there's any negative or positive impact on the performance, and then we can decide if we want to move on.
Awesome.
I'll let Michael now take the AWS Graviton part.
Awesome. Thanks you all for talking a bit about SundaySky's application and performance needs. My name is Michael, and I'm a partner solution architect at AWS, and I've been here for about 2 years. And let's talk about Graviton and how it kind of fits into this picture of performance and optimization. So AWS Graviton is our own line of ARM-based processors that power many different EC2 instances that you can run on AWS. These processors have been custom built by AWS and are running 64-bit ARM Neoverse cores. We've used our own experience of running high-scale workloads and understanding our own customers' needs to really target cloud-based performance that our customers are looking for. And we continue to innovate for our customers and focus on the performance and cost aspects that they need and are looking for on the cloud. And there's some great benefits our customers have seen from moving towards Graviton. Customers have been able to better optimize their workloads and see performance benefits. Whether they're running application servers or HPC jobs, customers have been able to realize great performance across many different workload types and use cases on top of Graviton. We've been able to offer a broad set of different instance options for customers who are looking to really target in performance of their workloads on top of AWS Graviton. Also, transitioning to Graviton and the ARM instruction set can be seamless. Many software providers support Graviton right out of the box. Operating systems like Amazon Linux 2, Red Hat, SUSE, Ubuntu all come ready to run on Graviton. Also, many of our software partners like Granulate have worked hard to support their own customers looking to make the transition. And many of them have been able to take advantage of its performance benefits, which allows their products to perform even better on their own customers' workloads. And finally, security posture can also be improved by taking advantage of Graviton. Features like always-on 256-bit DRAM encryption and faster per-core encryption performance is available out of the box for customers running on top of Graviton. And these instances are also taking advantage of Amazon's Nitro systems to monitor and protect hardware resources. And all of these benefits can be used across a really broad set of different workloads. Whether you're running web servers, gaming servers, HPC jobs, databases, media encoding, et cetera, customers can really take advantage of great performance at low cost. And we continue to innovate for our customers and continue to work towards providing greater support for our own customers' workloads and what they're looking to do on AWS. And to support these broad sets of workloads, to support these broad workloads, our currently available Graviton 2 processors power a broad set of different EC2 instances to match what customers are looking to run. We offer 12 EC2 instances powered by these processors, and we continue to build and develop so we can expand what customers can run on Graviton. Our first generation of Graviton was a single instance class. It was the A1 instance. And here we've been able to really expand with Graviton 2. And as of recent, we've come out with the IM4GN and the IS4GEN for storage-intensive workloads such as self-hosted databases. And we've also released the G5G for graphics-based workloads like Android game development and machine learning inference workloads. And as of last November, we started preview access to the next generation of Graviton-based processors, Graviton 3 and the C7G. And these Graviton instances here provide the best price performance in Amazon EC2 for a variety of different workloads. They receive 40% better price performance over comparable x86-based instances and are currently available in 23 regions globally. With that, switching to these Graviton 2 powered instances can help lower total cost of ownership significantly. Customers will still be using the highest performance instances within a given family and can do so at 20% lower costs when compared to similar instances. And this leads to overall 40% better price performance. So not only are customers getting great performance out of Graviton-based instances, they also get to do it at a lower cost. So customers don't need to compromise to get great performance here and to get those cost benefits. And not only does Graviton 2 have great price performance benefits, it also has support for many of the technologies you're using today. We support many of the commercial and community-driven operating systems, like our own Amazon Linux 2 and many of our partner operating systems like RHEL, SUSE, and Ubuntu. Additionally, many popular container runtimes can run on Graviton. The Elastic Container Service and Elastic Container Service for Kubernetes both have native support for Graviton-based instances, and Docker and Kubernetes also have support for ARM, the ARM instruction set, and can run on top of Graviton as well. Additionally, popular container registries also are ready to support ARM-based images. Both Amazon Elastic Container Registry, ECR, and Docker Hub can take ARM-based images that can be used to deploy your applications. And they also support multi-architecture images. So if you need to deploy across a mixed fleet of different instruction set architectures or different ISAs, you'll be able to do that all within a single image. And moving to Graviton, you can continue to use the great tools and software that you're already accustomed to. You can continue to run, manage, and monitor your Graviton-based instances as you normally would. Create your new ARM-based images with Image Builder and manage your configurations using Systems Manager. Continue to auto-scale your EC2 instances with AWS Autoscaling. And you can also continue to monitor your Graviton-based instance performance using CloudWatch. Also, our code suite of products is Graviton ready too. You can run your builds and tests natively in ARM using CodeBuild. Also, you can deploy to your Graviton-based fleets of EC2 instances using CodeDeploy. And not only does AWS provide tools and software that support Graviton in the ARM instruction set, our great partners do so as well. AWS Marketplace is ready to let you deploy software products and partner products to meet your needs on Graviton. Whether you're looking for continuous optimization like Granulate, CI/CD products, security products, and others, we have many partners who commit to building products that run great on Graviton-based instances. And with that said, we've been able to talk a little bit about the great price performance benefits of Graviton and what they can provide and the broad support that AWS and our partners have. So I'm going to send it back over to Yuval to talk about what the transition to Graviton for SundaySky has looked like.
All right, thank you. Yeah, so like I said before, in SundaySky, we always look for ways to improve our performance. So we started, I guess, a while back to test AWS Graviton. So the move to Graviton was quite easy, actually. It didn't require any code changes to our code base. We just needed to make some modifications to the way we set up our instances, and to use and use some other third-party packages like Splunk folder reviews and the Granulate agent, which we'll talk about later. We also had some issues at first with getting enough spot instances. All of our fleet runs on the spot instances. So we used a mixture of types. We used the C6G, R6G, and M6G, and that kept us safe on the spot area. And like you can see in the slide, on the right bottom you can see the number of instances, and the blue line represents the auto-scaling group that was using the Graviton instances versus the orange line, which used the C5 instances. And you can see that we needed to use less instances with Graviton. And on the top left, you can see that we kept the same beat time. which is the metric that we use to decide whether we want to scale up or down our instances. And you can also see that we have a better CPU utilization in the Graviton instances. And that led us to cost saving of 30%. Again, we use two autoscaling groups to measure our performance, and that goes the same goes for the cost. We can measure the cost for each group separately, and we can see here that the group that was using the Graviton instances was 30% cheaper.
Great.
Yeah.
Thank you, guys. Cool. So I will be speaking about Granulate real-time continuous optimization solution. My name is Bar, and I'm leading the solution engineering teams here at Granulate. So my team will be the one which is working with all of our customers. Of course, Yuval and SundaySky were one of them. Where the core premise behind Granulate, before we'll speak about how exactly we are doing what we're doing, the core premise is that operating systems were designed as off-the-shelf product with the user behind the keyboard in mind, and as for all of the mechanics which are related to compute resource allocation is built to optimize to support interactivity and fairness. So our experience as users won't be affected badly, whether it is on our MacBooks or PCs, whereas I will use a streaming kind of an example to illustrate what is the exact issue with interactivity and fairness when it comes to performance optimization. So we are looking here on few users who are trying to initiate a login request to Netflix service, something that I'm guessing most of us here on the call are familiar with. We are seeing that user request incoming to the front-end service on the homepage, the login service on the front end. Well, at that point, we would like to take several actions, like authenticating the user, providing that user with what's new or what's trending within his region. And we would like to provide that same user with custom recommendations. Now, of course, authentication and what's new are quite fast operations. You can imagine they will respond faster than the others. In our case, we are seeing that authentication and what's new responded faster than custom recommendations. What's new is, of course, something which is based on a region, a country, or a state, and therefore it is probably cached somewhere, whereas custom recommendations can be reside on an external database or a storage that can be, for example, an S3 bucket on AWS, which means it takes a little bit more time to provide a response compared to authentication and what's new. But looking for a second on that point in time where we got the responses from authentication and what's new, from our machine's perspective, the EC2s which are running on that login service, they will now need to allocate compute resources to process these backend responses. That can be CPU, memory, or simply network traffic, where we are actually providing zero progress to the application, to the business flow. Without custom recommendations, we won't have the ability to provide our user with a response. If we would have the ability to speak with the OS on that specific point in time, we will probably choose to keep on serving different users, additional users, increasing the total incoming throughput to Netflix service while reducing the end-to-end latency, probably the CPU usage as well, by applying real-time prioritization decisions which are tailored to our specific app, which is exactly what Granulate is allowing. So as mentioned, Granulate will be an agent-based solution. Our agents will be installed on a service you will choose to optimize. Well, after learning the application's specific resource usage and memory patterns, it will have the ability to reprioritize in real time, processing decisions in order to have more of a tailor-made resource allocation mechanisms to enjoy that improved performance. Our agent is built using two modules, a kernel module and a runtime module. Once a Granulate agent is being installed on an EC2, that can be an EC2 that runs an ECS, EKS, or a big data workload on EMR, It will load these two modules pending a discovery process where it will recognize the OS flavor, version, and kernel version. The kernel module will optimize anything that the kernel is managing. That will be the CPU scheduler, for example, memory mute access locks and acquisitions, file descriptor processing priorities, etc., etc. That same agent will also load a runtime module that will be loaded into the process itself, and it will be dependent on the runtime used to develop the application. For a JVM-based application, it will load a JVM-based module. For a Python-based application, it will load a Python-based module, etc., etc. The runtime module will optimize anything that the runtime manager masks out from the kernel. On JVM-based application, for example, that will be JVM thread pool, which will be a limited amount of threads which are being managed by the JVM thread pool and not by the OS itself. As for, we will apply optimizations on both layers, the kernel and the runtime layers. It is important to note, and Yuval can probably speak about it as well, we are required with no code changes, no R&D efforts, no configuration changes. Everything will be happening automatically. You won't need to do anything other than installing the agent, give it a few days of learning, and activate. With regards to use cases, Granulate support only Linux-based environment, where with regards to architectures that will be over the cloud, a mix of a public and private cloud. We are supporting all architectures, of course, AWS Graviton and ARM supported. With regards to microservices deployment, we will always reside on the node itself, but we do support EKS, ECS, Battle Rocket, etc., etc. And one of our major use cases will be big data. Of course, many of our customers will run them on EMR on AWS or self-managed big data running on EC2s, for all that matters. Now we'll speak a little bit about benchmarks that we did on Graviton, where what we're seeing here is a performance comparison between C6G for Excel and C5 for Excel, where we are looking on improved SLA and more throughput with Granulate compared to without Granulate, while we are simply providing equal performance optimization, no matter the actual architecture, where our customers are enjoying that in terms of reduced cost. We'll touch a bit about it in a second, but it is important to note that Granulate is first and foremost a performance improvement company, though most of our customers will utilize these improvements for cost reduction, not necessarily for improved SLAs. Here we are seeing jobs benchmark. Jobs will be Java operations, where we are seeing the same normalized critical jobs. With Granulate, we're looking at about 13% improvement in critical jobs, 61% improvement in SLA, while we're mitigating at about 18% SLA difference from Intel processors to less than 7%. Here we're looking on SundaySky and Granulate POC results. With regards to why Granulate mentioned, but always good to recover that, as many of our customers and partners will ask what we are covering here. So using Granulate will require no code changes, no R&D resources. It is very fast time to deploy. It's a CLI command, a C URL that can be integrated to any deployment method you have, Apache or Ansible. For Kubernetes, ECS, we do support a daemon set-based installation. POC in Granulate is super easy. You can start from one machine within a cluster within an account, and grow from there based on results. That's simply what we did with SundaySky. We are working on all infrastructures as mentioned, and a very important note would be that Granulate is completely task initiative agnostic. As currently we are optimizing performance from a software perspective, not from a hardware perspective, which is what we are currently seeing mostly. Using Granulate will provide you with added value regardless of any optimization you did before, whether it is configuration tuning, capacity management, or anything like that.
All right, so Yeah, like Bar mentioned, the deployment of Granulate was quite easy. We didn't have to make any changes. Only the startup script that set up the instances. And as before, we deployed Granulate on one of our autoscaling groups to be able to compare the performance impact on one group. And you can see here that on the right bottom, you can see the orange line is the instances in the autoscaling group with the Granulate agent installed. So you can see that we were using less instances and kept the same beat time. So it was pretty much straightforward to keep using Granulate. And also you can see that the performance, the cost difference between the two groups, and we saw 15% improvement in our cost between the different groups. Bar, you want to take it?
Sure. So speaking about the process of utilizing Granulate more in depth, I'd say, so first we will use our profiling tool, which called the G Profiler. For any of you who is not familiar with the concept of profiling, profiling is allowing you the ability to profile executions to the CPU, sampling these and seeing which executions, functions are you're spending most CPU time on. So we developed our own profiler called G Profiler, again, completely open source, completely free, where that will be the first step before engaging with the POC with Granulate. As by deploying the G Profiler on multiple workloads, we will provide you with expected improvement before you will do the actual POC. It means that you can go for a POC on any specific workload where you already know what to expect, which makes the G Profiler a very powerful tool in the decision-making process of whether or not you want to POC Granulate and when. Post G Profiler analysis, where you are seeing, I'm seeing that we have a question. Does Granulate improve memory utilization or memory consumption remain the same after deploying Granulate? Great question. Granulate will not optimize memory in a sense that you will probably not see reduced memory utilization. It doesn't mean that memory-bound workloads will not benefit from Granulate, as if you are bound to an SLA, that can be latency, processing time, throughput, anything like that, that will be optimized. And so if you are scaling based on memory, you won't necessarily see automatic cost reduction, as that metric will not be improved. But if you are scaling based on latency, throughput, or any other metric where you will see improvement by deploying Granulate, you will have the ability to enjoy cost reduction. And if not, then manual tuning of the ASG policy will allow you to see cost reduction as well. But as mentioned, Granulate will not reduce memory usage. So I hope I answered your question. Going back to the POC process, as mentioned, post G Profiler deployment, we will go to the actual deployment of the G agents, Granulate agents. As mentioned, Granulate can be deployed on few instances within a workload or few workloads within an account. The deployment itself is super easy. Post deployment, the agents will be installed in a passive mode. We are calling it the learning mode. It means that on the first days since the installation of Granulate, you won't see any change in performance. That will be same latency, same processing time, same job completion time on your Spark workload on EMR, as the agents will be learning the application-specific resource usage, memory patterns, and data flow in order to identify these bottlenecks and inefficiencies that we talked about that can be optimized by Granulate. The learning time will differ between runtimes, JVM, Python, Go, etc., etc. Post-learning time, you will have the ability to activate the agents through Granulate UI. It is important to note, during that learning time, you won't be needed with any efforts from your end. Just install the agents, give it a few days of learning, and off you go. We will optimize our performance. The latest part would be cost reduction, capacity management, where on that scenario, we're seeing practically two cases. One would be where the service is out of scale, where it's scale based on a metric that Granulate is improving. As for you will see reduced number of instances, you will scale less instances. In a case where the workload is not scaling based on a metric that Granulate will optimize, let's say a custom metric that's not necessarily seeing optimization, or the cluster is static scale, you will have the ability to right-click terminate on few EC2s, realizing the cost reduction manually. But again, super easy effort. And of course, one of Granulate SE will work together with you until you will seize the most cost reduction rate that possible. I'm seeing that we have a question: is the agent installed on each container? No, the agent will be installed on the machine itself. So it is always installed on the node. It is identifying different containers or Kubernetes deployments using the prefix, either a container prefix or a replica prefix, but it is always installed on the node.
Okay, thanks so much, Bar. We have a couple more questions. Yuval, I was asked, how does your monitoring tech stack look like? Which tools are you leveraging to monitor and track performance?
Like I mentioned before, we use the AWS CloudWatch. In addition to that, we use Splunk for monitoring and alerting, and that's it mainly.
Thank you. And Michael, you were talking about regions. Is there a significance between regions? If so, what?
Sorry, could you repeat the question?
You were talking about regions. Is there a significance between regions? If so, what?
I'm a little confused by the question. So regions, just to baseline, are large geographic areas, kind of where we're grouping data centers together. So these different regions are going to have different available EC2 instances. So we have, of the total regions we have, 23 of them support Graviton-based instances. So if you're looking for Graviton-based instances in each region, you'll have to double check that they're available there. So depending on what you're looking for, you have to double check that the instance is supported there. But we do have a broad support across those regions, across the globe, to make sure that you can take advantage of these great price performance benefits from Graviton wherever is best for you. If there's a region that you don't see instance availability in and you don't see Graviton availability in, feel free to let us know, and we'll do our best to try and provide that instance availability so you can get those price performance benefits that you're looking for. Hope that answers the question.
Perfect. Thank you so much. I'll just let our audience know everything is recorded, and you can feel free to drop questions and we can reach out after that. In the meantime, if we don't have any other questions, I'll step into this slide. If you want to learn more about AWS Graviton Processor, if you want to read about Granulate's and SundaySky case study, if you want to review Granulate on the marketplace or get a personalized estimation based on your workload, this presentation and this deck will be shared with you. All of these resources are linked. And if we don't have any other question, I will personally thank each and every one of you. Michael Lanthier from AWS, thank you very much. Yuval Kenigsbuch from SundaySky and Bar Yochai Shaya from Granulate. Thank you so much for this.
See you guys.
Bye, everyone, and thank you for joining us.